The controversial and mysterious Shroud of Turin, many believe it captures the exact moment of the resurrection.
You can see clearly the face here, the crossed hands, and here are the scourge marks. It's a photograph of the moment of the resurrection.
The lab fell silent when the algorithm finished processing. After months of feeding high-resolution scans of the Shroud of Turin into advanced pattern recognition software, the results were impossible to ignore. The AI had found something that shouldn't exist. For 7 centuries, this 14-foot linen cloth has sparked debate. Some call it the burial shroud of Jesus Christ. Others dismiss it as medieval forgery. But what artificial intelligence discovered in 2024 changed everything we thought we knew. The machine found mathematical patterns embedded in the fabric itself, geometric ratios so precise, so intentional, that medieval forgers couldn't have created them. The AI didn't just analyze the famous image, it decoded hidden structures that human eyes had missed for generations. When Dr. Sarah Chen first saw the algorithm's output, she thought her computer had malfunctioned. The AI was detecting mathematical sequences woven directly into the shroud's fabric structure. Not random variations you'd expect from ancient weaving, but deliberate geometric patterns following precise ratios. The most striking discovery? Golden ratio proportions appearing throughout the cloth's dimensions. The AI mapped 1.618 ratios in the spacing between weave intersections, the positioning of bloodstains, and even the facial proportions of the mysterious image. This wasn't coincidence. The probability of random occurrence was less than 1 in 10 million. But here's where it gets crazy. Medieval weavers worked by hand, using basic looms that couldn't maintain mathematical precision across 14 feet of fabric. The AI found variations in thread tension that created intentional patterns, requiring computational planning that didn't exist in the 13th century. Dr. Chen's team compared the shroud's weave structure to authenticated medieval textiles from the same period. The difference was staggering. While period fabric showed the expected irregularities of hand weaving, the shroud maintained mathematical consistency that modern industrial looms struggle to achieve. The AI detected something else: fractal patterns in the fabric's microscopic structure. These self-repeating geometric sequences appear at multiple scales, from individual thread placement to the overall cloth dimensions. Fractals weren't discovered by humans until the 1970s, yet they're embedded in this ancient linen. When the team fed the mathematical data into 3D modeling software, the results were unprecedented. The geometric ratios created a perfect template for the human figure that would later appear on the cloth. It's as if the fabric was mathematically designed to receive and preserve that specific image. The precision extends to the molecular level. Spectroscopic analysis guided by AI algorithms revealed that even the linen fibers themselves follow mathematical distributions. The cellulose alignment patterns match Fibonacci sequences, nature's mathematical blueprint that medieval forgers couldn't have known existed. Dr. Michael Torres, a textile historian at Cambridge, spent 6 months trying to replicate these patterns using period-appropriate techniques. His conclusion? Impossible. The mathematical precision would require computer-controlled manufacturing that didn't exist until the late 20th century. The AI also detected what researchers call intentional imperfections, tiny deviations from the mathematical patterns that actually strengthen the overall geometric structure. These aren't random errors, but calculated variations that enhance the fabric's ability to preserve and display the mysterious image. Most unsettling of all, the mathematical patterns seem to predict the image formation. The geometric ratios create focal points exactly where the most detailed features of the human figure appear. It's as if the fabric was pre-programmed to receive and enhance specific visual information. The scientific community remains divided. Some argue the patterns result from post-medieval restoration attempts. Others suggest the AI is detecting phantom patterns in random data. But the mathematical evidence keeps mounting, and no one has successfully explained how medieval technology could achieve this level of precision. The crazy part is this discovery emerged from analyzing the fabric structure, not the famous image itself. The mathematics were hiding in plain sight, embedded in the very threads that skeptics claimed proved medieval origin. The mathematical patterns were just the beginning. When AI-enhanced DNA analysis began processing blood samples from the shroud, the results defied everything scientists thought they knew about human genetics. Dr. Elena Rossi's lab at the Institute for Molecular Archaeology had extracted microscopic blood particles from 5 different stains on the cloth. Using machine learning algorithms to amplify degraded genetic material, they expected to find either human DNA confirming authenticity or animal blood suggesting medieval forgery. They found neither. The AI detected genetic sequences that didn't match any known human haplogroup in the global DNA database. Not European, not Middle Eastern, not from any population group catalogued in modern genetic records. The mitochondrial DNA showed markers that appeared human, but contained variations that shouldn't exist. And get this, the Y chromosome data was even stranger. The AI found genetic patterns suggesting a paternal lineage that terminated abruptly in the historical record. No descendants, no related family lines, no genetic cousins in any modern population. It's as if this individual's genetic line simply vanished from human history. Dr. Rossi ran the samples through 3 different laboratories to eliminate contamination. Each facility confirmed the same impossible results. The blood contained human DNA, but human DNA, unlike anything in scientific databases spanning millions of genetic profiles worldwide. The AI algorithms detected something else that shook the research team. The genetic material showed signs of extreme cellular trauma, damage patterns consistent with severe physical stress, blood loss, and cardiac arrest. But the preservation quality was unprecedented. Ancient blood samples typically show massive genetic degradation. This DNA remained remarkably intact after nearly 2 millennia. Most disturbing was the discovery of what researchers privately call genetic anomalies. The AI found cellular structures that shouldn't survive death, genetic expressions that typically shut down within hours of cardiac arrest. Yet spectroscopic analysis confirmed these weren't modern contaminations. The blood had been on the fabric for centuries. The contamination theory fell apart under scrutiny. Medieval forgers would have used animal blood, which shows distinct genetic markers. Modern contamination would display DNA from multiple sources, researchers, handlers, tourists who touched the cloth over decades. Instead, the AI found genetic material from a single individual with impossible characteristics. Dr. James Mitchell, a forensic geneticist who's testified in hundreds of criminal cases, reviewed the data independently. His assessment? The genetic profile represents either the most sophisticated forgery in history or evidence of something beyond current scientific understanding. The DNA analysis revealed another shocking detail. The genetic markers suggested Middle Eastern ancestry, specifically populations from 1st century Palestine. But the AI also detected genetic variations that don't appear in any ancient DNA samples from that region or time period. When the team compared the shroud's genetic data to DNA extracted from other claimed relics, no matches emerged. This wasn't recycled material from medieval relic manufacturing. The blood came from one specific individual whose genetic signature appears nowhere else in human history. The implications are staggering. Either medieval forgers somehow obtained and preserved blood from an unknown human lineage, or the shroud contains genetic evidence of someone whose DNA doesn't fit established patterns of human ancestry. The AI keeps processing new data, searching for genetic relatives or historical connections. So far, the search has yielded nothing. The DNA remains an orphan in human genetic history, present, analyzable, but utterly unique in ways that challenge everything we understand about heredity and human populations. The genetic mysteries were mind-bending enough. But when AI algorithms began analyzing the actual image on the shroud, they uncovered something that breaks the laws of medieval technology and possibly physics itself. The famous face and body impressions on the cloth don't just look like photographic negatives. According to machine learning analysis, they are photographic negatives, complete with 3-dimensional depth information that shouldn't exist in any pre-industrial artwork. Dr. Kevin Moran's team at the Digital Image Analysis Lab fed high-resolution scans into neural networks trained to detect photographic properties. The AI immediately flagged the shroud image as exhibiting characteristics identical to camera negatives, except photography wasn't invented until 1826, 5 centuries after the shroud's documented appearance. When you reverse the image tones, a perfect positive photograph emerges, not a painting that happens to look negative, but an actual photographic negative with light-to-dark value distributions that match modern camera technology. The AI calculated probability algorithms. The chance of achieving this effect accidentally through medieval painting techniques is essentially zero. But here's where it gets absolutely wild. The AI detected encoded three-dimensional data within the image intensity variations. Using computer modeling software, researchers extracted depth information and reconstructed a perfect 3D model of the human figure. Medieval artists couldn't encode spatial data into flat images. They barely understood perspective drawing. The depth information follows precise mathematical relationships. Areas closer to the cloth show darker image intensity, while recessed areas appear lighter. This creates a perfect topographical map of the human body encoded in grayscale values. The AI found this depth encoding extends to microscopic details, individual facial features, muscle definition, even skin texture variations. Dr. Moran's team attempted to replicate this effect using every known medieval artistic technique: painting, rubbing, stamping, burning. Nothing produced the photographic negative properties or three-dimensional encoding that the AI detected in the shroud image. The technology simply didn't exist. The neural networks found something even more impossible. The image shows no evidence of brush strokes, pigment layers, or directional application that characterizes all known medieval artwork. Instead, the AI detected what appears to be uniform discoloration of individual linen fibers, as if the image formed through some kind of radiation or energy emission. Spectroscopic analysis guided by machine learning revealed the image exists only in the topmost fiber layers, penetrating less than 0.2 micrometers into the cloth. This level of surface precision exceeds the capabilities of any medieval coloring technique and matches the penetration depth of modern laser etching technology. The AI also discovered that the image formation process somehow avoided the blood areas entirely. Where blood stains exist, no body image appears beneath them. This suggests the image formed after the blood had already dried and bonded to the fabric, a sequence that contradicts traditional painting methods but aligns with the physics of photographic exposure. Most unsettling, the computer models revealed anatomical accuracy that medieval artists couldn't achieve. The AI detected proper bone structure proportions, accurate muscle definition, and physiologically correct blood flow patterns. The three-dimensional reconstruction shows injuries consistent with Roman crucifixion techniques, including details about nail placement that weren't understood by medieval scholars. The photographic evidence keeps mounting, and no scientific explanation exists for how pre-camera technology could create these effects. The AI has essentially proven that the shroud contains photographic information that predates photography by 5 centuries, a technological impossibility that continues to baffle researchers worldwide. The photographic impossibilities were staggering enough, but the AI wasn't finished revealing the shroud's secrets. When pattern recognition algorithms began scanning for linguistic elements hidden within the fabric, they detected something that sent shockwaves through archaeological circles worldwide. Dr. Rachel Goldman's team at the Ancient Languages Institute had been skeptical when asked to analyze potential text on the shroud. Previous claims of hidden writing had been debunked as pareidolia, the human tendency to see patterns where none exist. But machine learning algorithms don't suffer from psychological bias. They detect actual mathematical patterns in data. The AI found them. Faint letter-like shapes emerge from digital enhancement of microscopic fabric variations, not random stains or fiber irregularities, but organized symbols following the structural patterns of early Aramaic script, the same language spoken in 1st century Palestine, the same language Jesus would have used. The neural networks detected approximately 40 distinct character formations scattered across different areas of the cloth. When linguistic analysis software processed these symbols, they formed partial word fragments consistent with ancient Aramaic burial inscriptions. The AI identified potential matches for Nazareth, king, and what appears to be an incomplete rendering of Jesus. But here's the crazy part. The text wasn't written on the fabric. The AI detected that these letter formations resulted from the same mysterious image formation process that created the body impression. The Aramaic characters show identical fiber discoloration patterns, identical surface penetration depth, and identical photographic negative properties as the main image. Dr. Goldman brought in 3 independent Aramaic scholars to verify the AI's linguistic analysis. Professor David Stern from Hebrew University confirmed that the character formations matched 1st century Palestinian script variations. The letter shapes, spacing, and grammatical structure aligned with burial inscriptions found in Jerusalem area tombs from that exact historical period. The authentication challenges are immense. Ancient languages evolve constantly, and forgers throughout history have attempted to create fake inscriptions, but the AI detected linguistic markers that weren't understood by medieval scholars, specific grammatical constructions and letter variations that modern archaeology only discovered through Dead Sea Scroll analysis in the 20th century. Most compelling was the discovery of what linguists call living language patterns. The Aramaic text shows dialectical variations specific to 1st century Galilean speech, pronunciation quirks that influenced how words were written. Medieval forgers wouldn't have known these regional linguistic differences, which were only identified through decades of comparative analysis of ancient manuscripts. The AI also found that the text positioning correlates with Jewish burial customs. The potential Nazareth inscription appears near the head area, while king appears near the chest, locations that match 1st century burial tablet placements found in Palestinian tombs. This cultural accuracy extends to details that medieval European Christians wouldn't have understood. Dr. Goldman's team ran the linguistic data through probability algorithms. The chance of randomly creating Aramaic-like symbols that match 1st century Palestinian dialects, burial customs, and regional variations is astronomically small. Either this represents the most sophisticated forgery in archaeological history, or genuine 1st century text preserved through the same impossible image formation process. The text discovery adds another layer to the shroud's mystery. If authentic, these Aramaic inscriptions provide linguistic evidence supporting the cloth's Palestinian origin and 1st century dating. If forged, they represent knowledge that medieval Europeans couldn't have possessed. The AI continues processing enhanced imagery, searching for additional text fragments. Each new discovery deepens the mystery of how this impossible combination of photographic, genetic, mathematical, and linguistic evidence came to exist on a single piece of ancient linen. While linguists debated Aramaic inscriptions, botanists were making their own impossible discoveries. AI-enhanced microscopic analysis of pollen grains embedded in the shroud's fibers revealed a geographic fingerprint that medieval European forgers couldn't have faked. Dr. Maria Santos, a forensic palynologist at the International Botanical Institute, had analyzed pollen evidence in criminal cases for 15 years. When she first examined shroud samples under AI-guided microscopy, she assumed contamination from modern handling. The pollen species she found shouldn't exist on a cloth stored in European churches for centuries. The machine learning algorithms identified 58 distinct pollen types embedded deep within the fabric fibers. Not surface contamination from recent exposure, but ancient pollen grains integrated into the cloth's microscopic structure during its creation. The AI mapped these species to specific geographic regions and flowering seasons with unprecedented precision. 33 of the identified species are endemic to the Jerusalem area, plants that grow exclusively in Palestinian soil, requiring specific climate conditions and mineral compositions found only in that region. Medieval Europeans had no access to these plants, no knowledge of their existence, and no reason to transport their pollen across continents for forgery purposes. But the geographic evidence gets more specific. The AI detected pollen from Gundalia tourneforti, a thorny plant that grows wild around Jerusalem and was historically used for making crowns. The same species mentioned in botanical studies of potential crown of thorns plants. The pollen concentration patterns suggest direct contact, not random environmental exposure. Dr. Santos found something even more compelling. The pollen assemblage matches the specific flowering season of 1st century Palestine. The AI identified species that bloom simultaneously only during March and April in that region, exactly when historical records place the crucifixion events. This seasonal accuracy couldn't result from random contamination or medieval guesswork. The pollen trail tells a story of geographic movement. Early concentrations show exclusively Palestinian species. Middle layers reveal pollen from plants found along ancient trade routes through Turkey and Greece. Later deposits include European species consistent with the cloth's documented journey to France and Italy. The AI mapped this botanical evidence into a precise geographic timeline spanning 2 millennia. Most remarkable was the discovery of Zygophyllum domosum pollen, a desert plant that grows only in specific areas around the Dead Sea. This species requires extreme soil conditions and produces pollen with distinctive microscopic markers that the AI identified with absolute certainty. No medieval European would have encountered this plant, much less transported its pollen to incorporate into a forgery. The botanical evidence extends beyond simple species identification. The AI detected pollen preservation patterns that indicate the original cloth was exposed to Palestinian flora during the dry season, then stored in conditions that prevented European pollen contamination for centuries. This preservation sequence contradicts theories of medieval European origin. Dr. Santos attempted to replicate the pollen assemblage using medieval transportation methods. Her conclusion? Impossible. The specific combination of Palestinian species, their preservation state, and their integration into the fabric structure would require direct exposure in 1st century Palestine, followed by immediate preservation in controlled conditions. The pollen evidence provides the most concrete proof of the shroud's geographic origin. While other analyses deal with interpretable data, botanical identification offers binary results. These plants either grew in 1st century Palestine or they didn't. The AI confirmed they did, and their pollen signatures remain embedded in the shroud's fibers as microscopic witnesses to an impossible journey through time. Every AI analysis deepens the mystery instead of solving it. Mathematical precision that predates computational technology. DNA that doesn't match human records. Photographic negatives created 5 centuries before photography. Aramaic text from 1st century Palestine. Pollen evidence mapping an impossible geographic journey. Science demands explanations, but the shroud offers only questions. Each technological breakthrough reveals new impossibilities that challenge everything we thought we knew about history, human capability, and the boundaries between natural and supernatural. What do you think the AI found? Let us know your theories below, and subscribe for more discoveries that blur the line between science and mystery.